But first, I want you to understand a little bit more about what Pearson correlation does and does not tell you. All right. So remember that if you see the letter R, that refers to the statistic Pearson correlation coefficient. All right. So it's called a coefficient. I don't know why. It is Pearson correlation coefficient, or just R for short. And it's always going to be a number. You're going to see R equals something, right? And then a number. Now that number tells you two things at a quick glance. So just instantaneously, by looking at that number, I'm going to be able to get a sense of how strong the relationship is between the variables. And I'm also going to be able to know if that relationship is positive or negative. In other words, I'm going to be able to know the direction of the relationship. Let's cover the strength of the relationship first. Now, what tells me about the strength of the relationship, whether it's, strong, medium, weak, absent, perfect, what tells me the strength is the actual size of the R value. All right. So if, let's say, I thought it was coming up on this slide. Well, I'll tell you what I was going to say, and then we'll look at this graph. What I was going to say is if the R value is very, very close to 0, then that is a very weak relationship, almost nothing there. If it's 0, it actually means there is nothing there. There's absolutely no relationship between our two variables. As the R value grows in size, as it gets larger, the relationship is getting stronger. But the largest value that R can take is 1 or -1. Could be -1 or 1. Either way, it is mathematically impossible to get an R value greater than negative or +1 unless you've made a calculation mistake. All right. But if you get an R value equal to 1 or -1, what you are saying is that the relationship is perfect. And that's why you can't get an R value bigger than 1 or -1, because perfect is perfect. You can't improve on that. So what I want to do now is explain what a perfect relationship is. And then we'll look at a relationship that is less than perfect. In other words, then we're going to look at real life. Because in real life, with social behaviors, we don't find perfect relationships. So that's why I said we're going to go to real life after we look at perfect relationships. All right, so here we have just two variables. We're going to start with the most simple case. So we're going to look at simple or bivariate correlation. We just have two variables, x and y. So these are all the values of x in our data set, and here are their corresponding values of y. And then what I've done is I've taken them and I've plotted them. So the first thing I have to do is plot 2 and 5. So when x equals 2, y equals 5. All right, see if we carried it across, it would line up with the 5. So I put a circle there. But I have to reinforce the circle 2 more times, right? When x is 2, y is 5, well, the circle just gets maybe a little bit darker, right? But it's still all in the same place. Now here, when x is 3, y is 8. So when I go over to my x-axis, I find the 3 and I go up to 8 and I put another little dot. And then I'm going to have to do that a couple more times because I have these as well. When x is 3, y is 8. When x is 3, y is 8. And then for the last one, x is 4, y is 11. So I find out where that is. This must be, I took a little snippet and I got my cursor in there. But here, x is 4 and y is 11. So you put another little dot and do that 2 more times. All right. Now, you can tell that this is a perfect relationship at a glance because if we were to draw a straight line through the scatter plots, through the dots on the scatter plot, you would notice that these dots all fall on the line. right? If you took a ruler, you could draw a straight line and it would hit all those dots. When that is the case and there are no dots that fall off the line, that means you have a perfect relationship. Now, what does it mean? It means that if you know X, you know Y, and you're never going to be wrong. All right, so here, if I said your score on X is 2, what is your score on Y? It's 5. Is it always 5? Yes, because whenever X is 2, Y is 5. There's no deviation from that. All right, so there's no exceptions. Similarly, if I said, okay, your friend scored 3, what was their score on X? You would say 8. Is it always 8? Is that always true? When somebody's score on X is 3, they always get 8 on Y? And the answer is yes. It's perfectly predictable. Same thing here. If somebody's score on X is 4, we automatically know their score on Y. It's going to be 11, and that's always true. Based on this data set, there is never a situation that deviates from 2 is 5, 3 is 8, and 4 is 11, right? So it's perfectly predictable, and you could draw a straight line, and all the dots in the scatter plot will fall on that straight line. That is a perfect relationship. Here's one that is less than perfect. Now, we could still draw a straight line, and a straight line would be a good way of describing this data, right? We can sort of see where a line could be drawn, and although there's some scatter off the line, I can easily visualize a straight line going through this data set. But now look at what's happening. If we look here and say, oh, X is 2 for this first person, and their score is 5. Okay, what about this next person? Their score is also 2 for X, but this time they have a score of 4 for Y. And this person, much like the first one, this person scores 2, and they have, like the first person, a score of 5. So if we look at when X equals 2, we can no longer say that Y is always going to be 5. There's some unpredictability here, right? Because most of the time it's 5, but sometimes it could be 4. Same thing, if we look at X equals 3, well, most of the time, the score, if you score 3 on X, you score 7 on Y. Most of the time. But look at this person, they scored an 8. So you see how it's not perfectly predictable anymore? And then same thing here. Most of the time when somebody scores a 4 on X, they get 11 on Y, but not all the time. All right, so there's unpredictability. This is illustrated in the scatter plot because if we were to draw a straight line through these points on the scatter plot, some of them could fall on the line, but others won't. So because not all the points fall on the line, that tells you that you can't use the line to make predictions and you're always going to be right. We'll talk more about the line and how we use the line to make predictions later, but that's kind of just a summary, okay? Here, if we drew a line, we could make predictions based on the line, and we'd always be right because all the scatter points, all these dots fall on the line. Over here, if we draw a straight line through the scatter plot, we're only going to be accurate using the line. We're only going to be accurate in predicting, making predictions for those points that fall on the line. Those points that don't fall on the line are going to be missed in our predictions, right? We're going to be off. All right. So let's look a little bit more at the values for R and, how the actual size of the R value tells you the strength of the relationship, and how the sign of the R value, whether it's positive or negative, tells you the direction of the relationship. We'll start with the strength of the relationship first. And I've already mentioned R can only take on a value between -1 and +1. It can take on any value in between, including 0, but you could never get an R value greater than perfection, right? You can't get an R value greater than +1, and you can't get an R value greater than -1, unless you make a calculational mistake. Now, what I've also said is that, well, I haven't said this. Let me explain this, and then I'll tell you what I was going to say. All right, so an R value equal to 0 means there's no relationship. If we were to plot the points, the XY points on a scatter plot like we saw on the previous slide, we would notice that those dots are all randomly scattered all over the place. There's no discernible pattern, all right? It looks like somebody took a shotgun and there was a lot of buckshot and it just like splattered randomly on your scatter plot, all right? Now, that's not true. Remember, if you have a perfect relationship, all the dots will be on the straight line. Okay, that's if it's perfect. So if it's +1, all the points will fall on a straight line. If it's -1, all the points will fall on a straight line. Now you might guess the line has to be different, right? In this case, the line is going to take on a negative slope. In this case over here, the line will take on a positive slope. I will show this to you very, very soon. Okay, now we have to explore a little bit about, what's happening between 0 and -1 and between 0 and +1. Well, hopefully you've already guessed it, right? I think I've said it, in fact, a couple of times now. As our R value increases in size, so as it's approaching +1, what's happening to our relationship between X and Y? It's getting stronger, more predictable. Same thing here. As our R value is increasing in size in the negative direction, that tells you that the relationship between X and Y is getting stronger. In other words, it's more, approaching perfection. It's more predictable. Okay? Now, as for quick facts, what if you have two R values? They're exactly the same size, all right, but they have different signs. So let's say we have 0.25 here and -0.25 over on this side. What can you tell me about those two R values? They are describing a relationship that is equally strong. So the relationship between two variables that have a correlation of 0.25 is the same in terms of its strength. It's just as strong as a correlation, an R value between two variables that has a correlation between them of -0.25. All right? So if I were to give you three R values, let's see, -0.9, +0.5, and +0.6. Which one would represent the strongest relationship? It would be the -0.9. When you're looking for strength of the relationship, you have to ignore the sign, okay? So erase it from your vision. Just look at the actual size of the R value. The larger that R value, the stronger the relationship is between your variables. Now, as a very, very rough guideline, if R is somewhere between 0.1 and 0.3, so if you get an R value somewhere around that range, we would say that that's a weak relationship between X and Y. Anything between 0.3 and 0.5 is moderate, and anything 0.5, or greater than 0.5 is considered strong. But you have to take this guidance with a grain of salt. Okay, it's only a guideline. Think of Pirates of the Caribbean. It's only a guideline. All right. And that's because whether, 0.1 to 0.3 is considered weak depends on what you're studying. All right. There are some relationships, for example, in psychology, when we're studying human behavior and personality and, I don't know, just anything psychological, psychosocial, there are so many variables that affect our behavior at any given moment. It is really hard to get strong correlations between any two variables. So we might actually find a correlation of 0.3, which would be weak in the field of chemistry, let's say, where they can control everything. All right, that would be embarrassing for them. If they got a correlation of 0.3, they would be like, okay, let's sweep that under the rug. We obviously did something wrong. But in psychology, a correlation of 0.3 might actually be considered at least moderate, right? So you have to take into consideration what it is you're studying before you can automatically say, oh, that's a weak correlation or a moderate or a strong correlation. Now, this it's like one of my little pet peeves that I have. I have quite a few. This is one of them. All right. So I'll say, what is a correlation equal to 1? We've defined what is weak, moderate, and strong. What is a correlation of 1? And somebody will say, very strong. And that's when I say, no, it's not very strong. It is perfect. There's a difference between saying something is very strong and saying something is perfect. If you have a perfect correlation, it means X and Y are perfectly predictable. When you know one, you know the other. If, let's say, you have a correlation of 0.9, well, that's very strong. It means that there's still unpredictability, but just a tiny bit. All right. So very strong and perfect are not saying the same thing. If you have a correlation of +1 or -1, that is perfect. You can't get any better. So make sure that you define that as perfect, not as very strong, as perfect, okay?